So we are continuing Mod 14. This is the second video in our Mod 14 group. We're dealing with solving exponential equations, but these exponential equations are occurring inside application problems. So we've got word problems to deal with here. We have two formulas that we need to know. Compounded n times a year versus compounded continuously, dealing with interest. So if we're talking about n times a year, if I said quarterly, that might mean that n is equal to 4. Monthly would be n equals 12. Daily, n equals 365. There are two that can be confusing. Semi-annually versus bi-annually. So if it says semi-annually is 2 times a year. So if we've got semi-annually, n equals 2. If we have bi-annually, that is every other year. So we let n equal 1/2. Because 1 year is the first half, the second year makes that a whole 2-year period. But when we start talking about compounding continuously, we use the PERT formula that you see here. So in these formulas, we have these different variables. They all have a meaning. The principal is our initial amount, present value. The A is our end amount, whatever we result with, or our future value. R represents a rate, and if we're talking about a rate, we want to make sure that that rate gets turned from a percentage to a decimal. And an example of that, like we might have 5.6%, and that would turn into 0.056 as a decimal. T, time, generally measured in years, and then N, a number of times compounded. So if it says continuously, if it says exponentially, if it says population, if it says half-life, we're going to be using the PERT formula. But if we read a word in the problem such as quarterly, annually, biannually, semi-annually, monthly, daily, hourly, that's going to mean nthly. And we're going to have to determine n is however many days. And like I said up above, if we said monthly, n would be 12. All right, so you want to be familiar with these two equations and then know how to use them. So our first example here, example 9, suppose that $2,000 is invested at a rate of 2.25% compounded quarterly. Assuming that no withdrawals are made, we're going to find the amount of money in the account after 10 years, and we'll round our answer to the nearest cent. So we're dealing with a word problem. The main thing I see is compounded quarterly. Compounded quarterly lets me know that n is going to equal 4, and it also lets me know I'm going to use my formula, A equals P 1 plus R over N to the NT power. So we're going to set this up with what we know. We have a principal, 2,000, and that is what was initially invested. So that's my P. And then we have a interest rate, 2.5. So 2.5%, R is going to equal 0.025. 2.5%, even though that's a percentage with a decimal, percent means per 100. So we're going to divide by 100, and that moves the decimal left 2 places. So my formula, my setup here, would be A equals 2,001 plus my rate, 0.025 over 4 to the 4t. So this is my function that I'm dealing with. And then we want to evaluate this at 10 years. So we could plug 10 in. A equals 2,001 plus 0.025 over 4 to the 4 times 10. So that means that our exponent is 40, and you need to be careful when you're typing this into your calculator to make sure that 4 and the 10 are both up in the exponent. So after you do this in your calculator, and I encourage you to pause and check and make sure you can get the same number, we get an A value that's equal to approximately 2566.05. So our end amount in the account is $2,566.05. Example 10. How much money should be invested? So that's asking us to find the principal. Now, how much money should be invested now at an interest rate of 7% per year, compounded continuously? Continuously lets me know we're going to use our PERT formula so that we have $7,000 in 5 years. So we've got some important parts here. Continuously, right away that lets me know I'm going to use A equals P E to the RT. I know that my interest rate, R, is going to be 0.07. I know that my end amount, A, is going to be $7,000. That's how much money I want to have at the end. And the time period we're considering here is that T equals 5. What we're being asked to find is the principal. So, write down the equation you're going to use. Make sure you have information to fill all of these pieces out. So we know A, we know R and T, and that's going to allow me to find P. And remember, E is not a variable. E is Euler's number. E is approximately 2.718. So in order to solve this problem, I'll plug all my values in. 7,000 equals PE, my rate 0.07 times 5, or 7,000 equals PE, that exponent becomes 0.35. So again, I encourage you to always multiply this exponent first and get that number if it's available to you, because it's just going to help you when you're typing it into the calculator. Most of the time when I see students working these problems, they can set them up correctly, but they run into technology issues in their calculator. So working through this, I can divide on both sides by that e to the 0.35, and I have 7,000 divided by e to the 0.35 equals p. And so simplifying this, typing it into my calculator, I get that p is roughly 4932.87. Or we can say we need to invest a principal of $4,932.82. I'm sorry, I'm looking at my number I've written down. That's 82 cents. All right. So example 11. Lisa needs $6,500 for future project. She can invest $5,000 now at an annual rate of 7.5% compounded semi-annually. Assuming no withdrawals are made, how long will it take for her to have enough money for her project? And we're going to round to the nearest hundredth in this situation. So what do we know and what do we have? And what are we being asked to find? We're being asked to find how long it will take. So that means T is going to be our unknown. So we need to find T. We have two formulas we can use. We need to determine which formula Because this says compounded semi-annually, that lets me know I'm going to use A equals P times 1 plus R over N to the NT. So I don't know T, that's what we're looking for. I do know what my N value would be because it's semi-annually. N is going to equal 2. Semi-annually is 2 times a year. So we know how much she needs. We know what the goal or the end amount is. So A equals 6,500. And we know what she has to invest. She has $5,000 at her principal. And then lastly, we know our interest rate. Our interest rate, R is going to equal 0.075. So I'm going to take all of those values, plug them in. That's 6,500 equals P, 5,000 times 1 plus my rate, 0.075, divided by N, the number of times compounded, which is 2, to the 2t power. All right? So simplifying this, one thing I always encourage us to do is to simplify what is in the parentheses first. So this is going to turn to a nice, it's a terminating decimal. It's not a decimal that runs off the calculator screen. So I'll go ahead and write that decimal on my paper. 6,500 equals 5,000. That value is 1.0375 to the 2t. So that just made it look a little easier to deal with. Now we need to solve for t, and t is in the exponent. So in this situation, we are solving an exponential equation. And when we're solving an exponential equation, we generally will use a log to solve. So as I work through isolating that t, I'm going to divide on both sides by 5,000. On the left, 6,500 divided by 5,000 leaves us with 1.3. I have 1.0375 to the 2t power. So here we will take either the log or natural log of both sides. There's no benefit to one or the other because we don't have an e or a 10. So now on the right side of the equation, that 2t can be written in front because we'll use our power rule. So I'll bring that down. The natural log of 1.3 equals 2 times t times the natural log of 1.0375. And then my last step solving for this, I can divide on both sides. And I could say that the natural log of 1.3 divided by both the 2 and the natural log of 1.0375 equals my t value. Plugging this into my calculator, I get that t is approximately 3.56, or that would be 3.56. My unit is years. And we know it is years because the interest rate says that it's annually. Okay? Last example in this video, example 12. How many years does it take for an investment to double? If the value invested is at 3.5% compounded continuously. We don't want to round in the middle while we're doing any intermediate computation, so we're going to keep everything as exact as possible. And at the end, we'll round our answer to the nearest tenth. So What are we being asked to determine? How many years? That is my unknown. T is what we don't know. We do know that it's compounded continuously, which lets me know I'll use my PERT formula. And then we also know our interest rate. We know that R is 0.35. So we know which formula we're going to use, which is A equals PE to the RT. But we do not know the principal and the end amount. Well, the good thing is we can use any value. And an easy value for us to choose would be to use 1 for the principal. And if we consider doubling that, then double 1 would be 2. So if we let P equal 1, then my end amount A would be double that, which is 2. I could use 10 and 20. I could use 12 and 24. It's really, we're just trying to pick numbers that are going to make our life easier. So I'm going to set this up, and I'll say that 2 equals 1E. My rate is 0.35 T. Now, I really don't need that 1 there because multiplying by 1 doesn't change anything. So we're solving an exponential equation. We want to find this T value, right? And in order to get that down, we're going to need to take the log of both sides. And in this situation, our life is much easier if we choose natural log over common log, because a natural log is base E, and I have an E in my problem. So I took the natural log of 2, and then I took the natural log of E to the 0.35 T. And the nice thing is, when I take the natural log of E, that cancels, and I end up with the natural log of 2 equals 0.35 T. And I can divide by 0.35 on both sides. The natural log of 2 over 0.35 equals T, gives me my exact value, which I can type into my calculator. And I'll end up with T is approximately 19.8. So we can say it will take 19.8 years for our investment to double if we invest it now in an account which pays 3.5% interest rate.